Hello class! Today we're going to learn about free fall. So far we've discussed motion only in the x direction. In this section we're going to focus on the motion in the y direction. Free fall only occurs if there are no other forces acting on the object as it falls towards the earth. Near Earth, all objects experience a downward acceleration that we call gravity. That's right, gravity is a downward acceleration. The higher you drop an object, the faster its velocity will be just before it hits the ground. In this class, we'll define up as positive and down as negative. The picture on the right shows a snapshot at equal time intervals of an apple dropping. The larger gap you see near the bottom indicates that the apple is accelerating downward. A neat concept about free fall is that the mass of the object does not affect its falling rate. Or, in other words, it does not affect the acceleration falling down towards the Earth. Any object dropped from the same height on Earth will fall at the same acceleration of 9.8 meters per second squared. However, air resistance creates drag on an object and slows its net acceleration downward, as seen on the figure to the left. As previously mentioned, the acceleration downward is 9.8 meters per second squared, which we define that value as gravity. The picture on the left shows a person, let's say Burke, throwing down an object from the top of the tower. This snapshot of the ball at equal time intervals of 1 second shows that the distance is increasing due to the acceleration of gravity. What do you expect the position time graph of this ball's motion to look like? Yay! You remembered, a parabola. Because the ball is accelerating downward, we use the variable y to indicate the motion is moving up and down. There are two changes to make when using kinematic equations for free fall. The first change is to replace all x variables with the y variable to indicate that motion is up and down. Second, replace the acceleration in the x direction with negative g. The variable g stands for gravity, which is the value of 9.8 meters per second squared. When solving a motion problem, keep these equations nearby. For our first example, let's say a stone drops from the top of a cliff. It hits the ground below after 3.25 seconds. How high is the cliff? Please press pause to try to solve this problem. The first step is to write our givens. Time equals 3.25 seconds. Y, the final y velocity, equals 0 because that's the ground. And the initial y velocity is 0 because the stone is dropped. And we want to find our initial height of the cliff, which is y naught. Now please press pause to figure out which equation to use with our givens and find. That's correct. The equation you want to use is y equals y naught plus vy naught t minus 1/2 gt squared. Now again, please press pause to figure out how to solve for y and to plug and chug to solve for the correct answer. Remember to cross out any variables that equal 0. When you rearrange to solve for y naught, notice that there are two negatives. The two negatives become positive. When you plug and chug, you should get 15.9 meters. Now before we solve our second example, there are a few notes about motion in the y direction I'd like you to jot down. The first one is that the velocity in the y direction acts at an object, maximum height is equal to 0, as shown on the figure to the right at point B. The second thing to keep note is that the velocity in the y direction at point A and point C are equal, but in opposite direction. And third, the time interval between point A and point B is equal to the time interval between point B and point C. Alright, now for our second example. Let's say a baseball player catches a ball after 3 seconds after throwing it vertically up. With what speed did he throw it, and how high did it reach? Please press pause to solve this problem. Here's the trick. When you first step, write our givens and finds, And the time here I jotted down is 1.5 seconds. That's because the velocity in the y direction at its maximum height is equal to 0. And we know already that it takes half the time for the ball to reach to its maximum height if we're given the total time of 3 seconds. The last given is that we define that the ball is thrown at an initial position of 0. Now please press pause to solve the first unknown, which is the initial velocity. The equation you want to use is Vy equals Vy naught minus Gt. Now please press pause to plug and chug and solve for the correct answer. Again, remember to cross out any variables that equal 0. When you plug and chug, you should get 14.7 meters per second. Now please press pause to figure out which equation to use to solve for the final maximum height, which equals y. Correct. The equation to pick is y equals y naught plus Vy naught, oops, I forgot t, minus 1/2 gt squared. Now plug and chug to solve for the correct answer. In this problem, the answer is wrong because I forgot to include time. Alright, in class we'll discuss what the correct answer is.